this is the WJEC A-Level Physics question from January 2011, question 2 on the Unit 2 paper. It's basically a two-source interference or Young's fringes question. In the question, student fires laser lights of wavelength 532 nanometers onto two slits that are separated by 0.5 millimeters. Firstly, we're asked to explain what it means to say that light diffracts at each slit. So we're simply going to say that the light spreads out when it passes through those slits there. Next, we're asked to explain what it means to say that the slits act as coherent sources. So here we're going to say that light from the slits, from both slits, have a constant phase difference. Next part of the question gives us the separation of the bright fringes on the screen as 2 millimeters and asks us to calculate the distance between the slits and the screen. So our standard double slit equation is lambda equals A delta Y over D. So D is equal to A delta Y over lambda. If we substitute in the values, going back to the question, A was the distance between the slits, 0.5 millimeters. Remember to turn the millimeters into meters. Delta Y is the 2 millimeter separation of the bright fringes. And the wavelength was the 532 nanometers. So again, don't forget to turn the nanometers into meters. Substituting those into the equation, we end up with about 1.9 meters. Last part of the question asks us to explain why, if one of the slits is covered, the dark fringes become brighter. Well, this is because at the dark fringe we've got destructive interference. Now, to have interference we need two light sources basically, and if we cover up one of the slits then we've only got one light source and hence we can't get destructive interference. Thank you for listening.